Charles' law states that the volume of a gas in a non-rigid container is directly proportional to its temperature. It can be modeled by the formula V1 over T1 equals V2 over T2, demonstrating how if the temperature of a gas increases, the volume also increases, or if the temperature decreases, the volume also decreases. This can be observed by heating a balloon with a hairdryer. At room temperature, the balloon is this size, but observe what happens when it is heated. As the temperature went up, the volume of the gas inside the balloon also increased, until it expanded so much that the balloon exploded.
Now it's time for some practice problems. A sample of gas has a volume of 2.8 liters at an unknown temperature. When the sample is submerged in ice water at 0 degrees Celsius, its volume decreases to 2.57 liters. What was the initial temperature? Okay, so to solve this, we first need to convert our Celsius to Kelvin, and we do that by having our 0 Celsius plus 273 will equal 273 Kelvin. Next, we need to use the equation V1 over T1 equals V2 over T2. And then we'll just plug our numbers from the problem into that. So we'll have 2.8 as our V1 and 2.57 as our V2. And then our T2 is 273 Kelvin that we just solved for. And we're trying to find T1. Okay, so all we need to do next is multiply 2.8 liters times 273 Kelvin over 2.57 liters. And then our answer comes out to be 297 Kelvin. And then if you subtract 273 from that, you end up with 24 degrees Celsius. Gas in a cylinder with a movable piston has an initial volume of 88.2 milliliters. If we heat the gas from 35 Celsius to 155 Celsius, what is the final volume in milliliters? So first, to solve this problem, we need to again convert our Celsius to Kelvin. So we'll have our 35 Celsius plus 273 equals 308 Kelvin. And then we'll have our 155 degrees Celsius plus 273 equals 428 Kelvin. And then we'll again use the equation V1 over T1 equals V2 over T2. And then we'll plug our numbers from the problem in again. So our V1 will be 88.2 milliliters. Our T1 will be 308 Kelvin. Our T2 will be 428 Kelvin. And for volume in these types of problems, your volume does not always have to be in the same units, say liters, as long as they are consistent. So for this problem, we can use milliliters and solve for milliliters rather than having to convert everything into liters. Okay, so we'll just multiply across and then divide. And our volume comes out as 123 milliliters. And then an easy way to check your work is by looking at your initial and final volumes and temperatures. So as we can see, our temperature went up, so we need to double check that our volume also went up, and it went from 88 to 123, so it definitely went up, so it's a plausible solution. So basically, all you need to know about Charles' law is the equation V1 over T1 equals V2 over T2. And when solving for T1 or T2, make sure your units are in Kelvin always. And then an easy way to check your work would be if your volume increases, your temperature also has to have had increased. And if it decreased, then temperature also would have had to decrease.